This is problem 42. A space vehicle accelerates uniformly from 65 meters per second at t equals 0 seconds to 162 meters per second at t equals 10.0 second. How far did it move between the times 2.0 second and t equals 6.0 second? Firstly, when I look at this problem, there's a uniform acceleration. I would want to identify that because that will give me, with that, I'll know which equation to use to solve this problem. I see that we have a change in velocity. So what we want is to know how far did it move between 2.0 second and 6.0 second. Final velocity minus initial velocity plus acceleration times time to solve for the acceleration, and this is because the acceleration is uniform. That's why we're using this equation. Solving for the acceleration, so the change in velocities was the final velocity is 162 meters per second minus 65 meters per second, and the change in time was 0 to 10 seconds. So the final time is 10 seconds minus 0 seconds, so that's 10 seconds. Okay, so the acceleration is going to equal, plug that into your calculator, is 9.7 meters per second squared. So it accelerates 9.7 meters per second each second. So now we have the acceleration of the vehicle. Now we can find the displacement of that vehicle, right? So to calculate the displacement from t equals 2.0 second to 6.0 second, I'm going to take a shortcut, right? So what I mean is that I'm going to use equation 12b, which is x final distance equals initial distance plus initial velocity times time plus 1/2 the acceleration times t squared. Okay, so the shortcut that I'm going to use is that in order to get the displacement, I would have to calculate this one. So I'd call this one 1, call this 2. You could plug and chug in your calculator to do this, but I'm going to do it out. I'm going to write it out. So what I could do is that the equation 2, or distance 2, is going to have the distance with the more it's going to have the time with more seconds, because basically we're starting, so this would be the starting time. Or I should probably go like this. I should use the times instead. So the starting time, because they're asking for the displacement, the starting time is 2.0 seconds. And the end time is 6.0 seconds. So I'm going to use that and combine them to solve for the displacement quickly. So to do that, so this is the final, the equation with the greater time. Final equation, I'll call it the final displacement equation. So it had 6.0 seconds. Now, in order to get the displacement, we have to minus the equation with the less time from the equation with the greater time. 2.0 seconds. And this is how we're going to get the displacement. So what that means is that the first equation, so that would be initial distance, initial velocity. Now we have 6.0 seconds, right? Because that's the time, plus 1/2. And the acceleration, we're going to use that. We know the acceleration, but we want to simplify the equation as much as we can. So we're going to leave it out until the last 6.0 seconds. And that's time squared, right? Now we're going to minus the equation with the lesser time. I'm going to put it in parentheses because we know that the minus sign is going to be distributed after. Initial distance again, plus initial velocity, right? So this one has the time 2.0 seconds, plus 1/2 the acceleration times 2.0 second, and that's squared, parentheses. Okay, so distributing that, we know that this is going to still be negative. This is going to go to negative. This is going to go to negative. Okay, so now we can combine them. So I'm removing the parentheses because I don't want to be writing over stuff. We can combine like terms. So initial distance minus initial distance. We combine the velocities, so that's plus. So the final with 6.0 second minus the initial with 2.0. We have the 1/2 the acceleration times the time square. So the first one would be positive because it's the greater one, right? Minus 6.0 second, and that's squared, minus the 1/2 a times 2.0 second, and that's squared. It's going to go away. You probably should just write it down here. We go to 0. So the initial velocity, 6.0 seconds minus 2.0 seconds plus, and we can factor this as well. The acceleration portion, we can factor it out just like this. 6.0 second, we can square that. So let me change this to a bracket. Minus 2.0 second, square that. So it simplifies the initial velocity in this case. Let me get my mark. Okay, there we go. The initial velocity is 65 meters per second. 6 minus 2 is equal to 4 second plus 1/2. The acceleration, if you remember, was 9.7 meters per second square. So that's 9.7 meters per second square. And the change in acceleration, the change in time for the squares is 6 square minus 2 square. I think that's 32 seconds square. And that equals a displacement of 415 meters. And so this is my answer, and I could give it in scientific notation as well. So to go over, to solve this problem, we need the equation, initial velocity plus acceleration times time, and we also need initial distance plus initial velocity times time plus 1/2 the acceleration times square. There you go.